Alright, I want to talk about converting binary numbers to base 10 numbers and then base 10 numbers back to binary numbers. I think it's easier to start out with binary numbers, and the key to binary numbers is this. Each one of these lines that I've drawn is going to hold a binary number, and in the binary world, these are your only two number options that you've got, 0 or 1. And here's how you work out what it means in decimal. Each one of these positions has a value. Just like in the decimals and the base 10 numbers, we've got the ones column, the tens column, and the hundreds column. Well, in binary we have the same thing, but it's not the ones, tens, and hundreds. It's the 2 to the 0 column, it's the 2 to the 1 column, the 2 squared column, the 2 cubed column, 2 to the 4th, 2 to the 5th, and so on. So, if I have a binary number, let's say the binary number 101, I see where this lives on my chart. It lives right here. So I don't have to worry about any of these previous things. Nothing's happening here. But I take this 101 and here's what I do. Everywhere where there's a 1, I record that number. Anywhere where there's a 0, I don't worry about him. But again, here there's a number 1. And you add the numbers together. 2 squared is 2 times 2, which is 4. And anything to the 0 power is always 1. So this number is 5. This works with any binary number that I might like to talk about. Let's get something more interesting. Let's say I talk about the number 1011. This is a binary number. And again, every place where there is a 1, I record those numbers and add them together. And everywhere where there's not, I don't. 2 cubed is 2 times 2, which is 4. 4 times 2 is 8. Plus 2, plus 1. In base 10, we call this 11. In base 2, we call it 1011. You use binary numbers in general to handle stuff from computers. So now let's try to go back the other way. We've already seen the number 101 in binary, which you used to write a little base 2 for, is 5. And the number 11 in base 10 is the binary number 1011. So let's try to go from base 10 back into binary. Just like we took the binary numbers and split them apart into powers of 2 and then added those together, well, if you start out with 5 in base 10 and want to convert it to binary, here's what you do. You try to figure out what is the highest power of 2 that can fit into 5. 4 is the biggest number that fits into 5. And once you've taken 4 from 5, you've got 1 left over. We rewrite 4 as 2 squared. You rewrite 1 as 2 to the 0. And that convinces you, and you've got your little chart of columns, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 4. I've got something for the squared column, so I put a 1 there. I've got something for the 0 column, I put a 1 there. Fill in everything else with zeros. You get back the 101, which is what you were expecting. If you take 11 in the base 10 system and again want to rediscover, because you're converting from base 10 into decimal, into binary, what it is, we already know the answer, but here's the process. You look at the highest power of 2 that you can fit into 11, and that's going to be 8. 11 minus 8 leaves me with 3. Again, I look at 3. What's the highest power of 2 that can fit into 3? Just 2 itself. 3 minus 2 leaves me with 1. You rewrite 11 as 8 plus 2 plus 1, again with this powers of 2 idea. And then you rewrite 8 as 2 cubed. 2 is 2 to the first. 1 is 2 to the 0. And again, you've got 2 to the 0, 2 to the 1, 2 squared, 2 to the 4th. These are your columns. And for the cubed column, you've got a number. I apparently can't count. It's a 3. For the cubed column, you've got a number. For the 2 squared, you don't have any 2 squared, so you fill that in with a 0. But 2 to the first and 2 to the 0 have 1, and we get back the number 1011. There's lots of different basis conversions that we could do in college math. But binary is the most interesting because binary relates to how computers work. So that's why we discuss binary numbers and their conversions. Powers of 2 are very important for binary numbers to work because you only have two options, 0 and 1. Our base 10 number system really does work the same way. When I write 11 in base 10, what I'm really saying is I've got not 2 to the 0 anymore, but I've got 10 to the 0, and I've got 10 to the first, because 11 is 10 to the 1 plus 10 to the 0, which equals 10 plus 1. This is our usual idea, I think, of number columns. This would be called the ones column. We'd call this guy the tens column because it's the one with the tens. The next column over we would have called the 100s column because it's the 10 squareds place. So it's the same idea, base 10, base 2. You've got these positions, and depending on what position you're in, you're worth more or less than previous ones. And you talk about these exponent powers. So I think that pretty much covers binary numbers, and I hope this helped.